Awesome. Thank you so much. Wonderful morning. And thank you so much, Anand, for being here. But before we begin, let me introduce you to the people who are already aware and also who are already not. So let me begin with your introduction and give a kickstart. All right.
Okay.
So Anand Chandrasekaran is the founder and the CEO of Match3Den, which we all affectionately call as MSD, and you also call Mahendra Singh Dhoni as such. So MSD, a computer vision-based artificial intelligence company, and at MSD, Anand and his team have been working on a proprietary framework for intelligent agents that powers a range of applications from industry across the globe. Right, from the retail to healthcare, MSD has been instrumental in bringing about intelligent automation. And with the body of experience that includes work with IBM, DARPA, Stanford, and many more, Anand is one of the few in the world with a combination of biology and neuroscience, hardware and neuromorphic engineering, and software and AI systems. Anand's experience and expertise spans a wide range of areas, including medicine, healthcare, and diagnostics using AI, scientific research, and mammalian brains, hardware and software expertise in building brains to defense related applications. And I can't wait anymore to introduce you to the one and only Anand Chandrasekaran. Thank you so much for being here, Anand. I am super excited, and we are all.
Thanks, Teja. Um, I'll start presenting in just a bit. Okay, so yes, we're Match3Den, and there's a lot of confusion about that. So the company's name is Match3Den, and over the years, we've also been associated with the name View.ai, and recently, and this is the name I'm also going to be pushing through this conversation, is we're trying to push our platform, which is called Blocks. So there'll be Blocks.ai. All of these names can get a little confusing, but they're all the same company, not separate subsidiaries, none of those things. We're all the same company, right? And I'll give you a sense of what it means and why we named our companies that way, and it'll make sense as we proceed with the conversation. Okay. Here you go. So this is what happened last night. So at 8:45, you can see the timestamp on my Slack message to my staff. I literally said, hey, they want slides. Give me slides. And this is how I put it together. So bear with me if my deck is not as polished as you guys might be used to, but hopefully it'll convey the story and it'll serve as an anchor for the conversation as we continue talking about this. Yeah. So let's get started. Yeah. So what I'm going to talk about today, right? We've been at this for a while, right? At Match3Den. So it's impossible for me to actually cover everything and to do justice to any single part at all. So what I'm going to give you is a little bit of a history timeline of who I am, why I am, and how all of this came about, because that lends itself to the background for what we're up to. And then I'm going to introduce you to Blocks, which is one of my agendas, and what I'm going to be pushing. And then a very, very, very abstract representation of what Blocks, the system architecture has, before zooming in on two sections of Blocks, which will make a lot of sense, because I'll go a little bit more deeper into that. And through those two sections, I'll hopefully convey enough about how we approach system building and what the different problems are in terms of building such a stack, particularly in the area of delivering AI to the world. And yeah. And I noticed there were a whole bunch of Match3Den folks on the call as well. So yes, Cringe Fest is going to start very soon. Yeah. Okay. So this is my timeline. So I'm over 40. I'm oldish, older than the people in the company. The company is pretty young. And in 90s India, when I was growing up, everybody became an engineer or a doctor. Okay, that's pretty much it. That was life. That was India, right? And that's what we were all driven to do. I was no different. I had no clue about what was going on in the planet, and yeah, so I decided, okay, I'm going to take up one of those choices, which is engineering. Academically decently inclined, so I got into IIT Madras, and then there was darkness. You join IIT Madras, and then you realize, okay, there is a lot more to the world, and I was pretty depressed with what IIT at that point had to offer. in terms of what I wanted to learn and what could be learned at that point. Today, the world is very different. Just to put things into context, there was no startup culture back then, right? In the late 90s, early 2000s period in India. There were not that many resources. The internet was badly working. And I even remember that when I started at IIT Madras, I was using the Lynx text browser to browse the web. And I think I used Hotmail. Yeah, so that's the world I lived in, right? And it wasn't very inspiring. It wasn't what I thought engineering could be, and I was pretty depressed about it. But luckily enough, during my period over there, I discovered neuroscience, a subject, or the study of brains. And I decided to change my fields, which is why, down here you have this, instead of going in a straight line, I took off on a tangent and went and did my PhD at Baylor College of Medicine in the field of neuroscience. So, so engineer with no biology background entering grad school, and I was working with genetic mutant mice, sticking electrodes into that brain to try to figure out how the brain wires itself up. So that's what I was doing. So I was doing that for 5.5 years, got my PhD, and then a transition happened saying, okay, fine, I know a little bit more about the brain. There's a lot more to be understood, but can I try to apply it? And so I entered the field called neuromorphic engineering. So this is literally building brains on chips. Right? So as opposed to simulating brains on supercomputers and stuff, neuromorphic engineering took asynchronous VLSI and sub-threshold analog VLSI and tried to build chips that could emulate the biophysics of membrane properties inside the brain. So what that means is ultra low power and very heavy compute, all packaged into chips that you could then try neural simulations on top of, right? So that's kind of what I was doing. I was doing that at Stanford. It's during this period that, I dabbled a little bit, was part of some DARPA projects and so on and so forth. But essentially, I also got a little jaded with this kind of work in the sense that hardware building has a very long gestation period. Seeing anything come out of that would take a decade or two. And I was a little impatient. And academia at that point had also soured for me. I abandoned the idea of becoming a professor. And so I did a few stints here and there as a consultant, worked in a startup in Palo Alto, things like that. But the goal was, by that time I decided, okay, I want to build brains and I want to build intelligent agents. And in trying to do so, I putzed around and got nowhere. And so that's where Ashwini Ashokan, who's my wife and co-founder of MathStreetDen, probably literally, this is how I'm going to narrate it for the rest of our lives, so that's going to become our version of reality. She hit me on the head and said, dumbass, you're not going to build anything. Because you're going to putz around trying to build moonshot projects, which will go nowhere, and you'll just have to abandon them, and nothing's going to happen. So why don't we all join forces? And there's a third co-founder of ours, Costa, who also comes from a similar background to me as mine, neuroscience and neural computation and stuff like that. And the idea was, why don't we build a company where we could take what we thought brains could be like, take the principles, and put it in a system where we can actually do something useful about it. So Ashwini, coming from a product and design background, dragged us over, started MathStreetDen, and said, okay, let's try to solve problems that the world has with the AI that you think you can build. And so that was the birth of MathStreetDen, right? So we come over to India. We actually go to Bangalore. I saw something on the chat about Bangalore and Chennai all sharing fun over here. Well, hey, we came to Bangalore and then we abandoned Bangalore. Sorry, Bangalore, but we moved back to Chennai, which is hometown, and we thought we could build a company in a better way over here, just because a little slower, a little bit more academic, and give us the time to actually build a large force. Because you can't build anything alone, and we wanted the time to experiment to figure out exactly what we wanted to build. So we had this vague idea that, hey, yes, we're going to bring generalized intelligence to the world. Now the question is how. And so the next transition, right? So we putzed around, tried to figure out how to apply our technology, had some limited successes, some pilots, but they never really went anywhere because the world wasn't ready to absorb a platform to build intelligence. This was, a little too early for that. The world wasn't really ready to use AI in applications. And so investors, including people like Sequoia, advised us that we should pick a vertical and prove that we can actually do something in it before we tried to sell the platform and do something more generalized. And so that was the birth of View.ai. So we took our platform, and since it was very confusing because we had done a lot of things in gaming and entertainment, all kinds of stuff, we collected all our retail-specific offering and created the brand View.ai so that there would be no confusion. And then we started selling all of our products to cater to the retail sector, and particularly to the fashion sector. So I don't know if the people from that period are around, but we spent months and years getting our technology and our models ready and able to cater to the fashion world. So the houndstooth was not checks is essentially a comment from our fashion analysts who were trying to teach us engineers what the difference is in terms of what mattered in terms of the attributes out there in the fashion world, right? So View.ai since 2016 has been doing pretty well. So we're making money. So which is a good part, and we're helping brands all over the world automate several parts of their processes. We'll get to the details in a little bit. Okay, but now that we've gotten some degree of success with View.ai, the time had come to go back to the roots of the company, what we originally wanted to do, which is to get a version of generalized AI out there in the world and power lots of View.ais in different domains, right? And so for the last year and a half, we have been quietly shipping Blocks, which is the underlying platform. So View.ai runs on top of Blocks, right? Blocks is the platform. It wasn't called Blocks all the time. That's also a name that we came up with over some time. It was originally just called the Math Stack, right? So Math Read and Math Stack, right? So View.ai ran on the Math Stack, and now it was time to take the Math Stack as Blocks and try to power use cases in completely different domains. Because our hypothesis was we had built the stack in such a way that it could be generalized. And while View.ai was very fashion and retail specific, there was nothing in the platform that said that that was the only thing it could solve. And so for the last year, 2 years, we have been quietly deploying Blocks in healthcare, entertainment, so on and so forth, different domains, solving their problems in much the same way we solved problems for the retail sector, because the problems are very similar, and I'll talk about that. And yeah, so now we're trying to sell Blocks. And here's the takeaway and the common theme that I want to stick to as we go through this conversation. I've gone in a winding path, right? Gone from engineer to neuroscientist to neuromorphic engineer to machine learning, data scientist, whatever you name it, all of those things. And finally, we've come to a place where it's actually all about engineering all over again. Because fundamentally, that is what gets things done. And machine learning and data science are just flavors of engineering. And once the mysticism about them disappears, they're just tools in an engineer's pocket to deliver products. And so, yeah, so we're back full circle. And as a CTO, I am again an engineer. In fact, as of today, I think it's probably been 2 years since I last built a machine learning model. Right? Of course, the people in the company build models every single day, but I don't identify myself as a machine learning engineer or a neuroscientist alone. I think I used to be, hey, I'm a neuroscientist, but today I think I prefer to be called an engineer, right? So that's the full circle. Yeah. Okay, so let's get to it. So as I mentioned, the past was View.ai. That was the vertical we built on Blocks. I'm not going to spend time on this. In fact, I'm not really going to talk about View.ai at all, other than to say we power a lot of different use cases, all the way from search to personalization, tagging, segmentation, targeting, you name it. All of those kind of products under the brand View.ai. And it's still operational, and it's going just fine. Yeah. Okay. So the flavor of today, Blocks AI, is what I would like to give you a sense of as to what it is, how we built it, and talk about certain parts and the problems in how we went about building it, right? So what is Blocks? Yeah. So I mentioned that we wanted to bring a certain flavor of generalized AI to the world. And that's kind of what it is, right? The world has gone through transitions. The world went the world made a transition to become mobile native. They went to cloud native, and we think right now is the decade of the world becoming AI native, right? Every business out there wants to use AI. Not every business knows how to use AI, and through blocks, what we're trying to do is give you AI in a box, right? It's modular building blocks. It's full of puns, right? I apologize. The name, everything is very punny, and that's who we are. That's perfectly fine. But these modular building blocks allow companies that are data driven or should be data driven to finally to plug in the flavors of AI that will allow their business to actually work, right? And so that's what Blocks is, and I'll give you a sense of what that means. So every data-driven business has three fundamental pillars to their organization, right? Pillar number one is they have content or inventory, products. They can be videos, media, whatever you call, even services. This is all content. This is the stuff that they need to sell. Okay, so pillar number one is about things that you need to sell as a company. And if you don't organize the data that represents that content, you're in trouble because you don't know what you're going to sell. You don't know how to keep track of your inventory. You don't know how to do forecasting for supply chain. You don't know anything. So you need your data organized before you can do anything. So pillar number one is all about bringing machine learning and data science to organizing your data. That's pretty much it, right? Pillar number two is about, well, you have content, you have product, you need to sell it to somebody. So there is an entire range of customers. So you need to understand your customers so that you can sell the right product at the right time to the right person. Right? So it sounds pretty obvious, but everything related to understanding those users, their behavior, and very specifically understanding their interactions with your content at a very deep and nuanced level is what pillar number two is about. So you make sense of the data and the relationships between your customers and your content. And that powers a lot of use cases, including search, personalization, marketing, so on and so forth, right? All of that comes under that bucket. Now, there's a third pillar. Well, you have your content, you have your users, that's fine. But businesses have processes that they need automated, right? So in every company, there is a process that people are following inside the company where they're taking data from one form and converting it into another form so that they can control their business interests. I'll give you specific examples. I know I said I'm not really going to talk too much about View.ai, but there are some very good examples there, right? In fashion, for example, you need to you need to do photography for your clothing inventory. So which means there is a process where you take garments, you hire models, you put them in a studio, you have them wear the clothes, you take photographs, and you create all those good pictures. You then clean it up with Photoshop and all that kind of stuff, and then you put them onto the e-commerce site. This is a process, right? Similar other processes, you need to create collections and bundles and figure out how to sell things together and so on and so forth. Well, you need processes and tools to do that. So all of these processes need automation because they're very manual. They used to be very manual. We amongst others, are trying to help digitize and automate all of these processes. So three pillars: organizing your data, making sense and delivering it to the right customers, and then automating all the processes to connect these things, right? So that's essentially the thing. And this contributes to this flywheel, everything from data capture, organization, search, personalization, automation, right? So that's what Blocks helps you do, right? And so the way Blocks is structured is that we have an underlying framework which we call data blocks. It's basically the scaffold that holds together all of this data, because it's all about the flow of data, right? You need the data to be extracted out of different platforms, data stores, and so on and so forth. They need to be standardized. You have pipelines to get them into the right place. Then you need to be able to extract that, whether it's for business intelligence or for the other algorithms or to deliver it. You need an underlying data platform that can support everything. That's what data blocks is. It's the pump. It's literally the plumbing, and it's very important. It's the scaffold on top of which everything else is built. On top of that, as I mentioned, there's everything to do with classification type work, whether it's in data science or machine learning models, to deal with all kinds of data, right? And today in Blocks, we deal with text, vision, audio, video, any kind of data, right? And we have tools to extract information and organize it. And the entire gamut of machine learning models and fields that deal with that kind of processing is covered under Xblocks. Okay, so and we'll talk about the details of what falls into some of these things, but these things are not in isolation, right? Each of these blocks has a lot behind the scenes. Everything from infrastructure needs to tooling to processes to getting all the plumbing in together and the engineering scaffold that holds it together, right? So that's true for a thing. In the machine learning world, you have this additional requirement, which is that you need to be able to build machine learning models. So there are tools to allow people to build models, whether it's in data science or machine learning, right? Xblocks is the block which I mentioned, connects the users to the content and allows use cases such as search, personalization, and so on and forth. And on top of this, you need to have an interface so that you can tap into all of these blocks and actually deliver products. The different use cases that need to be solved need an easy interface to get through. And so we of course power API layers so that people can build any application that they want. But we also have our own native applications, which are wrappers, dashboards, and so on and so forth on top of blocks, which can be used to accomplish these same goals. So that's it. That's Blocks. That's kind of how it's organized. And as I mentioned, View.ai was our first customer sitting on top of Blocks. And since then, we have started expanding horizontally. Right? Okay. And yeah, now this is, as I said, this is a very abstract version of our entire system. Obviously, it doesn't do it any justice. And people in the audience who are in my company will understand that, hey, those arrows make no sense, right? I know that there are 300 more arrows going in different directions and other parts that you're missing. But hey, this still helps to convey the idea. So I'll put this in front of you so that you get a sense of how things happen, right? So the intention over here is to read this slide from bottom to top. So all your data coming in from your customers, whether it's product data, content data, user data, process data, all flow into the system. And you have an entire set of compute layers that can extract and transform this information. And the way they do it is by leveraging models that are stored in a model library, right? So these models get used to transform the data. So models pertaining to different segments, different types of data, they all exist and they get leveraged the right way to convert this data into a useful form. Structured forms, and it's not just structured forms. Let me just digress a little bit. You want to store the raw data, because you always might have newer models that can make better sense than that. So you store the raw data, but the raw data is very imprecise. If you try to build applications on top of the raw data, you run into problems, which is why you need all of this, right? The second thing, as I said, is the tip of the pyramid, which is very structured data. So if you know, or you think you know, I need this data, you can build models to extract that data from the raw data, and you store it, and you can build applications on top of it. But that only goes so far, because you will find out that you can't explain certain phenomena. If you want to differentiate why some things are happening, sometimes the structured or the raw data don't convey the information. So what you need is to store all the latent information when you're converting data. So you take the raw data and you convert it into structured structured form, which is indexed and easy to search and use in applications. But then we maintain this latent space of vector data, essentially. So binary data that represents the data in very different forms. And when we are looking for meaning, we can query that layer to find more nuanced detail. I'll make this real for you. If you are looking at two red dresses, they're not the same. One of them is scarlet, the other one is crimson. Well, if you did not have structured data that said, this is scarlet and this is crimson, and the only resolution you had was red, how could you differentiate between them? So you need higher dimensional data that represents color. right? And so that's what I mean by that latent space. You have vectors that represent that higher dimensional information that you can tap into to make sense of things. And this is done automatically. We'll get to that in a second. So extract, transform, store all of this data, whether it's customer data or content data. You store it all, and there's an entire AutoML loop which involves workbenches that can manipulate, build new models, and plug it back into the system. Some are automated, some can be done manually. If people think they have new architectures, they can just plug it into the system. Okay. So on the other end, you need to do something with all this data, right? So this is where we power a very high-speed, multi-dimensional search. So mathematically, not everything can be broken down into a search problem, but practically on this planet, every problem that you're thinking of solving can be represented, mostly can be represented as a search problem. Who do I sell it to? What do I sell to somebody? What all do I sell to somebody? Who all look like this? They're all search problems, right? Which lead is going to convert? How do I score this person? How do I rank my leads? They're also search problems. They're just relevant where the search results are ranked in a particular way. So the ability to make sense of this data boils down to a very powerful search problem. And the models that manipulate the search to make it useful for all these different applications form another AutoML loop. Okay, so we have models that are used for extraction of information, and we have models that are useful for making sense of the connection between the users and that data. And they also live in the equivalent of a model library that get used when a particular application wants to use them. So this is it in a nutshell, right? So you have layers that transform the data and extract information, enrich it. A lot of plumbing to hold all of this together. Then you have layers that can convert any query that comes in into a very relevant and contextual search query, and then give you results very quickly for the relevant system, and applications that can tap into that. And obviously, data doesn't stop over there. It's not a one-dimensional flow. The interaction of the end customer with that query, with the results that you give them, what they did afterward, did they respond to an email you send them, every such piece of data also flows back. So it's a complete closed loop system where the feedback comes in and continues training both sets of models. Okay, so this is the blocks stack in a nutshell, right? Very abstracted, but I hope it conveys the big picture. And before we pause for questions, I'm just going to give you a couple more things. Our need for blocks has evolved to the point that we need to be able to deploy blocks everywhere. We have customers who demand that we run this only on AWS, customers who say this can only run in Azure. We have customers who say, okay, no, we're not okay with SaaS. Our data is not going to leave our system. You have to deploy inside our system. Our platform engineering team has come up with the tools that allow us to do all of this deployment at scale very, very quickly. Right? Take that with a grain of salt. It's still evolving, but yes, that is the premise of how blocks can be leveraged. So giving. So while this was nice and abstracted, the reason I can't go in much greater detail, this is an obsolete picture. And in fact, I got this from one of the people on the call, this is from a year and a half ago, and this is a component diagram of what went into an Azure deployment. And it is, as you can see, it's very messy and very complicated with all of these things coming together. But that's the whole point, right? You need all of these infrastructure tools to be able to build a data-driven organization. And our premise is, no, you don't. You just take blocks, and we can take care of all of this plumbing. And all bells and whistles are included, right? And the important thing, and so I threw this up. This is also an example from last year. I believe Kirtana was an intern at that point, and then subsequently became a full-time employee. But as an intern, she was able to deploy blocks with a single command line statement inside a new environment. And of course, that doesn't end the job. Of course, then all control planes management have to happen. You have to connect the business logic to it. But our entire platform can be deployed very, very quickly. And then if connected to the right paths, can start delivering value very, very quickly. Okay, and supporting that as well is a growing organization that handles cloud operations and stuff. And that's the joke over here, which is obviously you need all of this running very well. Right. So I will, as I said, there are two sections that I'm going to now focus on, and we'll take breaks after the two sections, right? Something like that. Okay. Okay, so one of the sections, so I can't obviously do justice if I try to cover every section of the company. I'm going to talk about Xblocks. Xblocks is all things related to data organization, right? And you'll understand what I mean as I continue talking about this. Now, what you're seeing in front of you is probably ridiculously familiar to anybody who has dabbled in machine learning, right? You have data, you have all these frameworks, TensorFlow, PyTorch, Keras, you name it, all the tools that you have. You get your data, you split it into train val groups, then you build models, you try all the different architectures that you want, or you come up with your hypothesis for how it's going to work. You train it, you get a model, you have an isolated test set, then you assess whether the model actually did well. You get your all the different metrics for machine learning that are relevant to model building, and then you have results for the model. So familiar territory. This is what people start with when they're starting with machine learning. Now, in an organization, life isn't so easy, right? So where do you get your data from? Do you trust your data? How much data are you going to get? Are you going to, is this data across multiple data stores? Is it journaled? When did you get it? Who validated it? Who actually provided labels for it? And then how are you going to try different architectures? How are you going to see whether this is the best model you have? What are you going to do about model drift? There's a ton of stuff, right? This is the world of machine learning that simple framework is great to get started with on toy problems and stuff. But the reality of deploying and running MLOps, amongst other things, as the right word for it, is very complicated. So there are lots of peripheral pieces that have to go into actually managing how an organization does machine learning, as opposed to one person doing the, machine learning on their computer with the GPU, probably, right? So we have obviously been building these tools for ourselves. I mean, we've been doing machine learning for a lot of years, right? So we've gone through the different frameworks. I'm trying to even recall the first one we ever started with. Wow. I don't remember the name of the first framework we started with and tried using it. But there was a time when we were even writing CUDA code and all that kind of stuff, right? So Costa and I come from a world where, slight tangent, Costa, the co-founder I mentioned, he was one of the first people on this planet to use CUDA to accelerate neural computation, right? Back in 2006-07, when CUDA was in beta. So we've come from that background, right? And frameworks didn't even exist at that point, to the point where I think there was a time when our company was evangelizing Chainer. And since then, we've adopted PyTorch, TensorFlow, so on and so forth. It's happened. And in terms of our distributed training framework and so on and so forth, we use something called Ray. That's the current flavor. It seems to be doing pretty well for how we do it. So I'm just giving you a few names, right? These are jargon names, just name dropping, so that you guys get a sense of what goes behind the scenes. But there's a ton of engineering to connect all of these parts and the tooling that goes to actually utilize it, right? So that's kind of how you do training at Math Street 10. Now, that's developing one model. Fine. But solving a problem is not about one model. And this illustrative diagram over here is how a model would typically actually get deployed. So if you take, say, our fashion models as an example, to extract information about fashion products, I believe the current graph that's inside the company has something like 70 different nodes, 70 models that are orchestrated together to get the contextual information. They break down the problem into its hierarchy and then bring it all together and blend it together to get the final output, right? They take different types of input, they take image, they take different types of structured and unstructured text from the input SKUs, and then they dissect it, put it all back together, reconcile, and then get you your output in a useful form. So machine learning and model building is not about building the one model. It is about building an entire graph of models, right? That have to be connected together and the information flow handled to go through. This is what we do. This is how we orchestrate our models in our inference machines. Side note, most tech companies have their naming nomenclature. I mentioned that I'll make my teammates cringe, right? So here's cringe factor number one, factoid number one. I have insisted and forced everybody in the company to name everything after DC characters. So yeah, we fight Marvel, right? So it's all DC. In fact, the original stack was built in one room in a corner of the office. So we call that the Bat Cave. And so the first few microservices that were built out of that were Batman and Robin and Superman and things like that. And Gotham was the architecture and so on and so forth. So anyways, the inference framework we have is called Nightwing. And so Nightwing allows us to do complex graph orchestrations in real time, synchronous, asynchronous, handle streams, batches, whatever you name it. We have our engines that have been home built, right? So that's part of it. Now, but here's the thing, just to complicate things a little further, the same nodes and models, say I said 60 models are in one particular graph that deal with fashion data. Some of those models can be used for, I don't know, grocery data. Right? Or healthcare data for that, for whatever it's worth, right? Because we don't know which models are actually going to work. When you find the models that work, and these graphs have to exist, the inference engine that we have built allows us to blend all of them together. So the data flows in, the packet of data. So that one quantum, which consists of the images, text, etc., for one context, flows through this graph, dynamically decides how it's going to flow, gets all of the input from all of the models, and comes out. And this entire complex graph orchestration is handled by Nightwing inside our system. So, and this is all engineering, right? This is not machine learning, this is engineering. I repeat what I said earlier, right? This is the fun, this is what's starting to get really fun, right? Machine learning model building, there's a lot of cool work happening, right? In terms of building new architectures and trying out new theories, but deploying it and at scale is a fun engineering problem. And we derive a lot of pleasure out of solving problems like these, right? Especially when we have to deal with volumes that are ridiculous. As I mentioned, we have customers all over the world, and some of our customers have volumes that are so high that if we had not built this, by the it was historical happy coincidence is that the plan to build this and the customer who would have broken our old system, they kind of came at the same time, and just in the nick of time, the first version of this was rolled out at production before they hit us with production loads. And they were at an order of magnitude greater volume than we had ever dealt with in the older system until Nightwing 3, by the way, this is Nightwing version 3, was able to handle that kind of traffic. So it's complex, and these are the kind of things that you need to build to actually deliver AI at scale. Right. And again, just name dropping a few components of what allow us to do this. We use Kafka, obviously, for streaming all that information through it. Orchestrating the information flow between all of these nodes is currently handled by Kafka. I'll get to that in a second. And obviously, you can't do this without leveraging Kubernetes and containerization at scale. Right? So Kafka and Kubernetes, obviously, there are a lot of other pieces that go into building this, but I'm just pointing out the two major factors. Without Kafka and Kubernetes, we probably could not have launched this when we launched this. Now that we've done that, I can tell you, we're already considering changing this. Right? Again, going back into, we're the company which will continue researching to make this better and better. So it turns out Kafka is great, but not necessarily for how dynamically we start switching graphs around. When you want to be changing partitions and topics and all that kind of stuff, don't worry, that's Kafka jargon. But the point is, it isn't exactly well suited for the kind of switching and dynamic changes that happen in our networks and our orchestration. So we're already considering some kind of hybrid method where Kafka plays a role in what we do, but we are introducing elements that will be a little bit more robust for the dynamic nature of the graph changes. So this is the inferencing. So I mentioned the training framework. This is the inference framework. They go hand in hand, right? So you need to build models, and then you need to be able to deploy it, right? So we have spent a lot of effort to reduce things to click this button, right? And behind the scenes, a ton of stuff is happening to make it real, right? And this is particularly important because you need to be churning out models and experiments at a scale that allows your business to keep growing. And if you can't reduce your problem to a single button click, of course, you shouldn't do what Rocket did and make things simple. You can't actually deliver things at scale. You won't grow as a company. And so this has been one of the efforts in the company, which is to constantly abstract out the complexity of the engineering systems into press this button and your work will get done. So time for a little tangent. You will notice that these are Marvel images, right? With great reluctance, I allowed the corruption of our decks with Marvel images, because the person who gave me these slides has been fighting me for the last 2 to 3 years to bring Marvel into our naming convention. Anyways, tangent aside, this will be the last time you see any Marvel references in the slide deck. Everything else will be DC. In fact, actually, hey, you have to launch it on Nightwing, which is DC. So point is everything, right? From launching the machines, running the experiments, tracking the experiments, distributing, collecting all that information, getting visualizations for your machine learning experiments, to finally picking out and saying, okay, I need that in production. They're all built into the stack. And a lot of it can be done from single button clicks. And that's the evolution of the stack, right? Tools are consistently built so that the engineers don't need to necessarily do it. And so here is a slide directly related to the previous slide. Note that this stopped in 2020. I have to remind them that they should have been continued tracking the analytics for this. But the slide was given to me from a snapshot from last year at some point. But the migration to this particular training tooling, the tooling that went behind the training infrastructure, when that went live, what used to be the throughput of the company, of course, take this with a grain of salt. Obviously, we have hired more people as well, but it doesn't account for this kind of rapid growth. The number of models that were generated in the early days required a heavy machine learning engineering hand-holding, right? Because you needed to understand what was happening in your models before you were able to deploy it. But continuous working on the tooling and abstraction of the machine learning problem allowed non-technical people, fashion analysts, for example, in our company, to start generating models and plugging them into production system. And so this graph, I know it's cut off over here and it's continued, but the idea is that fashion analysts, once the tool went live, started contributing like crazy. And so this accelerates the pace of development of AI models and deployment in production, right? So all of this is to result in something like this at the business end. Now, we've gone even further, and now let's switch back to blocks, right? So that I spoke about training, inference, and the plumbing and the necessity for tools. Now, what is blocks going to do? And this is something that's coming your way sooner rather than later. I'm going to talk about the Xblocks dashboard or product a little bit and give you a sense of what's coming. So we have gone all the way from, hey, button click in Jupyter notebooks, and here you can do things in a few steps and get a very high throughput, to, hey, you don't need to do any of those. Can we reduce your problem to organize your data, and that's all you should be doing, and everything else behind the scenes is automated for you. So we are going to be launching Xblocks, the no-code model building tool, later this year, and open it up to a lot of people, right? So now let me just give you a little bit of detail of that, right? So what do you need to do, right? So the first order of business in terms of organizing your data, it's very important. You need a taxonomy. You need to understand how you're going to structure and organize your data so that you can then organize your data. So Xblocks, the tool, comes with very visual elements that allow people to very rapidly build and modulate all their taxonomy, how the business-related information of how they want their data organized, and then plug it into the machine learning without having to ever lift a finger, right? All of that will happen automatically. The second part about that is a very visual interface where you can organize your data. So it's more of a drag and drop clustering organization type tool where all kinds of data can be sorted and organized very rapidly. So people simply have to start saying, okay, this is the taxonomy I want to use. I will now say that, okay, this data belongs to that node of the taxonomy. This other data belongs to that node of the taxonomy. And behind the scenes, we have active learning loops and medium-term learning and long-term learning. All the orchestration that I mentioned will all happen behind the scenes, that when a user finishes organizing their data, the normal MLOps processes do data exploration, EDA, take that data, train your models, test it, deploy. No. Organize your data and you're done. That's the principle behind Blocks.ai. There is no other step post that. Because as you were organizing your data, your models were getting built. You didn't know about it, but they were getting built. As you finished organizing your data, they were already deployed because they were assisting you to organize your data so that you can organize, annotate, label, visualize everything in real time. There were models being built behind the scenes, and all of that's happened. Compression, further long-term learning to reduce the dimensionality of how many models you're using, that can also happen, and they're all hidden, right? And it all happens right there. And so once you've done that, literally all you have to do is you can export your data or you can deploy your model. And deploy your model, as I mentioned, is that your entire taxonomy, the entire orchestration, that complex graph that we spoke about to do a job, because the taxonomy is not just about what is the color of this dress, it is everything together. Those complex graphs are automatically derived and deployed for you in the Nightwing infrastructure. So it's already live and production ready by the time you're finished organizing your data. So what is Xblocks? Xblocks is the tool that will allow any organization to literally go in and build their models without building the models. Okay, I'll pause here. Let's go to Genblocks. Yeah. Okay. So I'll give you a sense of it. Okay. So for the portion of the community in this meeting who are not aware of what those guys were referring to, let me just give you a quick introduction to what the problem is that was solved in View.ai specifically. Genblocks is one of those things which is not completely made its way into the blocks for other domains. Its primary use case is still in fashion and retail. So that's still the case, but it is definitely built on top of the Blocks platform and will make its way into general availability at some point. Okay, so here is the problem. Here's a dress. There's a model. Clothe the model. This is traditionally done through a photo shoot. Now, can you automate it? That's it. That's the problem statement. So the reality is it's not that simple. You have models of huge varieties in gender, shape, ethnicity, all of those related things. In fact, some of our customers say, hey, can you clothe the mannequin? So all of these kind of situations exist. So there's a huge variance in the target set in terms of models. If you also have synthetic models, 3D models, and so on and so forth. Yeah. And then the input to this is the garments themselves, and people who take photos take them in every possible way you can think about. Bad lighting, all kinds of artifacts, all kinds of weird orientations for you to be able to extract that information and be able to automate these things. So this is a very tough data problem, right? But for the last several years, we've been one of the pioneers, I would say. I hate using that word. It sounds very made up and artificial, but it is true. Costa in particular, our co-founder, has been leading the effort on adopting generative networks, generative adversarial networks. That's GANs is the word you might have heard from the world out there. That technology and adopting it, a particular variant of it, which is conditional GANs, and then made his own, modified it to actually solve this problem, right? So where we can take a garment, take a model, and create a generated model, right? And we don't, and it's not just that we clothe them in exactly this thing. The actual output can look like this, with a lot of variation. You can have models with a lot of different poses and a lot of different accessories. I don't know if you noticed, but this model is wearing sneakers in some, pumps in others, sandals in others, maybe so on and so forth, right? So these are the kind of generated outputs. This is the fundamental product. It's called View model, and all kinds of categories are being generated. So mostly clothing, but we're continuously adding to the kinds of things that we can generate and automate. So that's model gen in a nutshell. So I'll just keep it here for a second so that people get the sense of it. You need garments. You need to segment them, transform them, put them on the put them on the model, and that takes care of all the distortions of cloth, lighting, shadows, everything that you need to do. Account for the pose of the model, which includes if it's a full sleeve garment, obviously the sleeves have to be draped on the model. All of that it's all handled, right? So this is what it does. And taken to production, here is like a production ready output of the View model team. So you can see that here's a very nice high resolution example. By the way, the world of GANs out there is teeming with tons of papers that handle low resolution generations. These are all high resolutions, e-commerce ready, even up to 4K we can generate and deploy in production at scale. And so here's an output. Obviously, it looks pretty good. I'm not going to judge the quality, but you can see that we can do pretty well, right? So model, different poses, generation, and there's an entire process. Now, and we can generate clothes in different dimensions and make them fit the model or the target model, right? So in this particular case, you can take a small size dress and make it fit onto a larger model. Apologies for the joke, but you get the idea, right? Small size to XL to XXL. The business proposition is very clear. You need to be able to generate it in different ways. Okay, so how do we do this, right? It's complex. It's not that easy, right? And the standard problem is data, as most of you know. How do you create enough data to handle all the variance that's out there in the fashion world? And it is a fairly complex workflow that involves real data, synthetic data, creating all kinds of training sets for all the variants that, including the gaps that the real data does not cover, whether it's for people, whether it's for clothing, and paired sets of in different lighting conditions, whatever it is. These data sets are created in a complex flow, which then go into the training neural networks, conditional GAN training, and all that kind of stuff to generate the models that are able to generate all of that stuff. In addition to all of this, which is the operation of creating all of this data, there's also the tooling, the business end of how do you generate and deliver this to the customer. You need to generate tools. If you just generate things, who's going to do the quality control? How do you decide how to pair this shirt with that pant and so on and so forth, right? So the entire tooling, this is all engineering, right? Whether you have a client portal where the client says, "Hey, these are the images, these are the products that I want generated, tomorrow." Upload them, decide on how they want them styled or merchandised, and so on and so forth. And then an entire tooling that goes. Runs the automation part, includes QA, any minor corrections that are needed, and submitting it back for feedback to the customer, any loops that are involved, everything. Right? It's not simple. So this is what the View model team does, right? So everything from the tool building for the client side or the internal tools, all the pipelines that create data for training, which includes real and synthetic data, all the retraining loops, because when we are generating new and newer outputs, they can flow back into further training. The entire gamut, and then the entire research into generating new models that can handle different types of generations, whether it's for different poses, different accessories. It all exists, and this is a large organization in itself. Okay, so I'll pause at this point. So this, the story that I'm trying to tell you is, sure, you can take GANs. Yes, model generation can be done using GANs, but you can never go to production with it, right? It's fickle. You need to be able to train it. You need to create an entire infrastructure to create training data for it. You need to create the entire tooling and the pipelining system to be able to generate all of these things efficiently so that people can process a large volume of such products coming in from the customers, and to be able to deliver it with a high degree of quality. This is an entire pipeline and process, which is about org building, engineering, and process building, right? The machine learning part of it, while complicated and a constant track of research inside the company led by Costa, is one part of it. And that's the reality of building AI companies, right? There is so much that has to go into it, which is why as I mentioned, today I think of myself back as an engineer and less of a machine learning or a data scientist engineer. Yeah. Okay.
By this time, everyone out there has enjoyed it so much, and we had an absolute fun talking to you. Thank you so much for and thanks for
No
joining
problem.
in.
Yeah. Thank you.
So, if there is any last words that you wanted to share with of the audience, just go forward.
Hey, come join Man Street then.
Who wouldn't not to? They always whisper to be there.
And if you have data-driven problems, consider becoming our customer.
Absolutely. So, and also, if you have any other questions, you can feel free to reach out to Anand via LinkedIn, and he's pretty famous on LinkedIn, Twitter, everywhere. So you can try it out.
You could try Twitter DMs. I don't tweet a lot, but I'll respond if you DM me on Twitter.
So thank you so much, Anand, and thank you so much for each and every single one of you who've been patient for almost 3 hours, spending a whole lot of time listening to it, a lot of wisdom, a productive Saturday morning, and I hope you would have a great day ahead. Thank you so much.
Thank you.